Yes, good morning to all of you. Myself, Mahesh Jagdish Pingle, lecturer Electronics Engineering, Government Polytechnic, Ambad. So, dear students, today we are going to discuss the concept of amplitude, frequency, and phase. So, what exactly we mean by amplitude, frequency, and phase, right? So, that three concepts are very important while talking about the modulation process. So, let us have a look over these particular three parameters of a signal. Now, suppose if I will draw this particular signal, so right, so suppose it is x axis, right, and it is y axis, right, so x axis and y axis. Now if I am drawing a sinusoidal signal over here, so this particular signal, it is called as a sine wave. So sinusoidal signal, so it is a sine wave, right? Now at that time the x axis represents time and y axis represents amplitude. Since the signal it is in time domain, so it is also called as a time domain signal. So in time domain signal, x axis represents time and y axis represents amplitude. If on x axis there is frequency, then such a kind of representation, it is called as a spectrum. So we are not treating it as a signal, this becomes spectrum. So spectrum is nothing but the representation of that particular energy on x axis frequency and on y axis amplitude. So if on x axis there is a parameter frequency, then it is called as a spectrum, and if on x axis there is a parameter that is called as time, then it is called as a signal, right? Now here we are observing for every point on this waveform the amplitude is different. So at this particular point the amplitude is 0, suppose at this point amplitude is 1, here 2, suppose the peak amplitude is 3, then once again reduction 2 1, then once again it becomes 0. In negative axis, so there is -1, -2, peak amplitude -3, then -2, -1, and once again it becomes 0. So at each and every point on this particular signal we are having a different amplitude of the signal, so variation in the value of the signal. So suppose this is, we are having a voltage 1 volt, here 2 volt, 3 volt, once again 2 volt, 1 volt, 0 volt, -1 volt, -2 volt, -3 volt, -2, -1. These are nothing but the variations in voltage. So these variations with respect to time is plotted here. So these variations are labeled as amplitude. So at this particular point amplitude is 1, at this particular point amplitude is 2, at this particular point amplitude is 3, similarly up to this particular point. So every time we are having a change in value, and that particular change in voltage level, it is defined as the amplitude. So first concept we have cleared, amplitude is nothing but the that voltage levels with respect to the time, right? Now suppose this is your half cycle and suppose this is your also half cycle. So combination of two half cycles becomes one full cycle. So total number of cycles passed within 1 second, right, within 1 second, it is called as frequency. So frequency is nothing but total number of cycles passed within 1 second. So if cycle is 1, then it becomes 1 hertz, 2 cycles are passed, then 2 hertz, right? So how many number of cycles passed within 1 second, that decides the frequency. right? So while defining the frequency, number of cycle passed through 1 second. Now one cycle becomes, it is combination of two half cycles. So this is your half cycle and this is another half cycle. So these two becomes a full cycle, right? So we understood the concept of amplitude, then we understood the concept of frequency. Now then third parameter, it is nothing but the phase. Now here you are observing the nature of sine wave, right? Now I am drawing one another diagram over here, and at that time the nature is like this way. So here you are observing positive half cycle, here it is a negative half cycle. Here you are observing a negative half cycle, at that particular point it is a positive half cycle. At this particular point, if you are having observing positive half cycle, it is negative half cycle. Means there is a change in phase. So phase shift gets changed. So as soon as the phase of the signal gets changed, it becomes cosine wave. So sine wave becomes cosine wave because there is some phase shift between this particular signal. So phase is nothing but change in angle of that particular signal. So if there is a 90-degree change in angle, there may be 180-degree change in angle, 45-degree change in angle. So all these angle related terms comes under the category of phase. So phase, it is nothing but the term that is related with the angle, right? So these 3 points we have discussed. Amplitude, so this is nothing but the instantaneous change in values of the signal are represented by amplitude. 1 volt, 2 volt, 3 volt are nothing but the different amplitudes of the signal. Then within 1 second how many cycles you can send, that will decide the frequency, right? And the angle of the waveform, it decided by your phase type of term. Why we are interesting of discussing these three terms, that is amplitude, frequency and phase, because while doing the modulation process, one of the term gets varied and another two terms remains constant. So if you are varying amplitude of the carrier signal, then it is called as amplitude modulation. If you are varying frequency of the carrier, then it is called as frequency modulation. And if you are varying the phase of the carrier, then it is called as the phase modulation. So that part we will discuss in detail in our next lecture. So meanwhile we will stop here. So thank you very much.